This is going to be a lighter talk, more in the spirit of uh, waking up your minds on what smart manufacturing is. And smart manufacturing, like so many topics, is a very hot topic of the day. And it reminds me of my own career in nanotechnology in the US only because if you kind of rewind 20, 30 years when I was doing research on that topic, it was a very hot buzzword. Everybody was kind of jumping on the bandwagon. They were saying that they were also a nanotechnologist. And nanotechnology is about very, very small things. And even people who were doing chemistry, for instance, who were working with molecules and atoms, were saying, I'm also a nanotechnologist. So that's kind of happening in the smart manufacturing world right now, where everybody wants to get into smart manufacturing, but there's not a lot of understanding, right, on what it actually means. Yes, there is a lot of English, there's a lot of buzzwords, but I think if I can make you take away something from this talk, it's the fact that it is not as complicated as it sounds. And you can, as manufacturers, actually get started on something that is smart. So that is probably the most key takeaway from not just my talk, but the whole day of the conference today. So with that little introduction, let me dive right in. And what I have is just a few icebreakers. I'd like to present this the way I understood smart manufacturing, and also to dumb it down a little bit, not because people are dumb, but I think if you start with a very simple explanation, I think it actually drives home the point and people remember something from it. So I'll start with the first example here, which says luxury cars. It's not what you're thinking. It's not about manufacturing of luxury cars. It's not about high quality components or tight tolerances, which these vehicles are known for. It's more a personal experience. So recently, a few months ago, my wife and I were just chatting. Should we go in for a luxury car? We have had regular cars for so many years. At some point, everybody, that question springs to mind. Do you really want to go in for a luxury car? And we were just having a normal conversation across the table. And my mother was sitting on the side, and she interjected and said, no, there's no way you should go in for a luxury car because our Indian roads are not meant for that, right? The roads are filled with potholes and it's a nightmare. The traffic is difficult. India is not a country where you would want to invest in a luxury car. You want to actually drive it around. So that got us thinking, right? Is that one more factor to consider? But then we thought about it overnight and we came up with the exact opposite answer. We came up with the answer that in a country like India, where the roads are not that great, is where you probably need a luxury car because it shields you from the ups and downs of the road, right? So this is in some sense reverse psychology because you're saying that luxury car is probably too expensive for Indian roads, but actually that is what you need because you want to shield yourself from a bad road. You want a great suspension. You don't want to feel what is bad. And if you want to get into that kind of purchase, that is what you would expect from a product like that. So smart manufacturing is also like that. The initial pushback when I mention the word smart manufacturing that I get from anybody who's into the manufacturing industry is this really something for India? Right? Is it, in India, and I've been in the manufacturing industry. At Ashok Leyland, I don't do manufacturing, but my previous job in the power industry, I was running production. And we just needed to get the job done. That was it, right? We had to meet deadlines. We had to give product to the customer on the promised date. And then we had to manage our supply chain. And that was it. It was a day-to-day firefighting experience. Somehow we needed to get the job done at the right quality. That was the only thing on our mind. So something like smart manufacturing was far away, right? But I think looking at it in a different light, India is where you actually need smart manufacturing. Because the typical problems that you would have with smart manufacturing is the typical problems that you have with Indian manufacturing is what some of the facets of smart manufacturing can actually help you solve. And I'll run through some of those examples in the talk today. Right? So keep that in mind, right? The question is not whether you need it. I think the question is how you can use it. So that's one example. Second one, I don't know how many people are familiar with that word. It's called MEMS, MEMS. Anybody familiar here? Yes. So it's an acronym that stands for microelectromechanical systems. It's a technology that started off in the 1970s roughly. And a lot of you are using it maybe without realizing you're using that technology. It's the technology of making mechanical parts on a very, very, very small scale. Very small scale, right? So when you do manufacturing, you measure things like surface roughness on the order of microns. Here, the entire mechanical part is of the size of microns, the entire part, right? So what you're looking at is actually an image taken in an electron microscope, not even a regular microscope, of mechanical moving parts. As I said, 50-year-old technology, right? It's not new. And this was my bread and butter when I was working. And if you just see the bottom left corner of that picture, if you notice, there is a person with a finger holding a chip in his finger. And that chip is a mechanical chip. It's a silicon chip inside which you don't have any electronic circuits. You have all mechanical moving parts. You have gears, you have motors, you have all kinds of mechanical parts. And what you're seeing in the picture is some kind of a rack and pinion kind of part. And if you power up that chip and if you look into the microscope, when powered up, you will actually see moving parts on the chip, right? So why am I saying this? Because 50 years ago, people invented this technology. And then the first question that came to mind was, how do you manufacture something like this? It's so small, right? To give you a rough size comparison, the human hair has a thickness, not length, thickness, of about 50 to 100 microns. And you're talking about machines which are of that size scale, right, of the thickness of a human hair. So how do you potentially manufacture something like that? And of which, now I said roughness is on the order of microns, but the roughness of these parts would now be even smaller in the nanometer scale, right? So completely new technology, and it's a separate lecture on why you want to make mechanics smaller. There are many, many reasons you would want to do that. But how do you manufacture something like this? And there was innovation. There was a lot of smart ideas, right? In other words, people figured out that you can actually borrow a lot from how electronics is manufactured, just the manufacturing part, not the electronics, the physics, the devices or anything, right? So they actually used printing techniques called lithography to make parts like these. So similar process as electronics, but you don't make electronics, you make mechanical moving parts. So another brainwave that happened 50 years ago, which I would include in smart manufacturing because it is a very different thought process in terms of how you manufacture something with extreme reliability. I mean, these are parts that simply cannot have defects at all. So quality is at another level, right? So another example of smart. And a third one is more of a lighter vein kind of example. If you look at those parts, which are lids on top of vessels, what fails in those things, right? It is almost always that plastic knob on top that fails. It is not the metal part that fails, right? The metal part is actually designed well, it is manufactured well, and it never fails. But almost always at home in your kitchen or wherever you use this, it is that plastic knob that fails. So this happens in my house as well. There's a whole variety of different shapes and sizes of these plastic knobs, and you can almost never get an exact one-for-one replacement for these plastic knobs. So believe it or not, and this doesn't just apply to plastic knobs, it even applies to anything similar, like a fan regulator knob, for instance, right? They have so much variety in that I mean, it is impossible to find an exact match, right? Especially if you have an older part. So I bought a 3D printer on Amazon, 15,000 rupees. That's all it costs. And could figure out a way to custom make these knobs at home. Why am I saying this? Because for a plastic manufacturing process where you would think that the answer has to be mass-produced injection molded parts, there is actually a market for more expensive 3D printed parts, just because the supply chain works like that. You cannot find the parts that you're looking for, right? And when I started making my own knobs at home, and of course, my family was happy, a lot of my friends who saw that started placing orders for knobs because everybody had the same problem, right? So in this context, 3D printing of plastics is actually the smart way to do it. That's the point I'm trying to make, right? Normally, a 3D printing of a plastic is not the smartest way to manufacture it, but there is a context in which it actually makes sense. Final example, there is a process called TRIZ. I'm sure quite a few people have heard about it. It is a Russian acronym. And if you expand it in Russian and if you translate to English, it translates to Theory of Inventive Problem Solving. So it is a process to innovate. Normally you would think innovation is just some idea that you dream up, right? But this puts a process to it and it helps you innovate and come up with new ideas when you can define a problem, an innovation problem in a certain way. And we had a problem. So we said we wanted to use certain materials in manufacturing which are very, very, very high strength. So in particular, we wanted to use high strength steel, where the normal strength of steel, as you probably know, is about 250 megapascals. We wanted to use some steels that are about 6 times as strong, about 1500 megapascals. And what is the problem with using materials that are that strong? You can't manufacture it, which means you can't bend it, you can't do most manufacturing steps just because it is way too strong, right? So if you present that problem to a tool like TRIZ, right, saying that I want a material that is strong because I have a design use case for that level of strength, but at the same time, I don't want a material that is strong because I want to manufacture it. It's a classic conflict that you define. And this TRIZ process actually likes conflict type definitions and it helps you solve it quite easily. So there's a TRIZ principle called separate in time, which means it asks you the question, do you want it strong and not strong at the same time or at different times? And the answer is you actually want it at different times, which means that when manufacturing, you want it to be less strong, a lot less strong. After manufacturing, when you're actually using that part in the field, you want it to be very strong. So you're separating the constraints in time. And it gives you some ideas. And in this case, the answer is actually simple. It's not something that we invented. It's been around for a long time. You start off with a certain material alloy, which is not strong. You do all the manufacturing steps, and then you do a certain heat treatment step, which increases the strength all the way about 6 times, right? So solution is simple, but the answer is, the process of arriving at the solution is smart. So to me, all of this is smart manufacturing, right? It is not only IoT and sensors and data and AI/ML and all that, okay? I think everybody at any kind of industry, you could be a micro or a small or a medium, or you could be a large industry. there is something to take away from smart manufacturing. And to me, all of this falls within the gamut of definition of smart manufacturing. Yeah. So with that little introduction, I don't have too many slides, but I just wanted to give you this flavor that smart is for everyone and it's the right thing for India. So there's one more facet of smart, which is smart is not just efficient, it is also resilient. And this is an actual case study. In 2017, there was a fire that disrupted Toyota's supply chain, and they could actually use just real-time digital dashboards to reroute their entire production and essentially reroute it through a different set of suppliers. And within 72 hours, they were back in full swing. Right? That's all the time it took after a fire that completely disrupted their supply chain. Right? So this is another aspect of smart. It is also how resilient you are. If something goes wrong in your factory, how can you come up, not just make excuses, but how can you come up with a solution and get back on your feet as fast as possible, right? So this is another facet. Okay, so this is more of a mandatory slide, and you will hear a lot of this the rest of today. But I just wanted to put it here for completeness. These are the 5 main pillars for smart manufacturing, right? I don't want to belabor the point. I'll just very quickly go through it. So one is connectivity. How well you can get your equipment connected, how well you can get yourself connected into the system, how well you can get your vendors connected. All of this comes into place, right? And then you have predictive analytics and digital twins, which means you have a simulation of certain critical things that happen in your plant on your computer. And that simulation, the more accurate it is, the better it is. And if it's completely accurate, it's a perfect digital twin, which means if something is going to go wrong, you would see it in your computer first. It's a real-time live simulation that you're running on your computer. Digital twins apply not just to manufacturing, but it applies to so many different things. If I'm running an electric car, for instance, I can have a digital twin of my battery that's running anywhere, perhaps on the cloud. And then if something is going to go wrong in my battery, I can see it first on my simulation. So that's the essence of a digital twin, right? And predictive analytics comes along with that because I want to know when something is going to fail before it fails. And this is a huge deal, right? I mean, if one of the critical pieces of equipment in my shop floor is going to fail next week, I'd love to know today. Right? It is a combination of a lot of things. It's typically a combination of data and AI. For example, in Ashok Leyland, trucks, a key failure point is the clutch. And it's designed like that. It's designed like a fuse. You want the clutch to fail first, thereby protecting other things. Right? So if somebody overloads the vehicle, somebody abuses it, or just the clutch is nearing its end of life, then that is what fails first. And I want to know my clutch is going to fail before I embark on a long trip. Otherwise, I'm stranded in the middle of the highway. And when I know it's going to fail, I can actually do something about it. Same thing in manufacturing. I can plan, right? Plan preventive maintenance. I can change parts if I know that something is going to fail. Third one is autonomous operations. To the extent it applies to you, right? Which parts have to be autonomous, right? Are you stuck with some portion in your production line, which is, for example, highly skilled. And therefore, to the extent possible, do you want to automate it, right? It could even be a simple step like welding, for instance. And welding of certain materials is a highly skilled job. It could be a step like CNC programming, right? It's a highly skilled job, but today there are tools to automate something like that, right? Then human-machine collaboration. The future is tending towards not just robots running a plant, but how humans can work along with machines. It's called a cobot today. So how do you work in a combined environment where a robot is your assistant or you're the robot's assistant in some way, and you can actually make that combination effective. Finally, sustainability, never to ignore. It's becoming a big, big deal. And if you ignore it, your customers will probably enforce it on you. So with that, I will just show you a little video. This is a BMW video just to show you what smart manufacturing is. This is specific to them. It's an OEM. I know it's not a component manufacturer, but just to give you a little flavor of how other people globally are actually thinking of smart manufacturing. So if you look at the right side, one of the biggest facets of smart manufacturing is that 70% of manufacturers are investing in digital twins. Digital twin, as I said, is a real-time simulation. They want to know what's going on. And they want real-time scientific simulations of the real equipment, but based on actual conditions that the equipment is subjected to, right? And then leading companies like BMW and Tesla. And okay, anybody knows who this person is? He's the father of lean manufacturing, and his name is on the slide. His name is Taichi Uno. Two major historical events that happened in automotive smart manufacturing. The first one is the introduction of the assembly line, and that happened with Ford, right? It's a very simple concept in hindsight, but it's just the idea that if you can divide your manufacturing sequence into equal-sized, time-sized portions, then you can actually put it in the form of an assembly line, which means that you can actually achieve the kind of throughput that you can think of. And the second one was lean manufacturing by Toyota. And both of these, I would say, were very smart inventions at that time, right? So if you look at the list of lean manufacturing points, and I'll just read it out quickly. So it talks about waiting time with no value add. It talks about overproduction, which is just making too much. It talks about overprocessing, which is non-value added activities. Unnecessary transportation, excessive movements of motion, inventory, and poor quality and defects. So if you think about it, there's actually no magic in this list. There's nothing really surprising. So anybody who's doing manufacturing here will find this list extremely obvious, which means that if you were to independently go and take a list, you will probably come up with very similar items, right? So what is the big deal that lean manufacturing brings to the table? The only big deal is that somebody like Mr. Taichi Ono actually took the trouble to observe his shop floor and make that list. And that's about it. So he made a list. He said, this is what will solve my problems. And then he actually came up with a few measures to tackle that list. So that was about it. So I want to break this myth saying that smart manufacturing is not about some exotic list of items that somebody created and it's very hard to follow, but it's just something that you would go on your shop floor, observe your shop floor, and take a look and say, these are my pressing problems, right? And because these are my problems, this is what I want to solve. And that's all it is. And that's all that Toyota did in this case, right? So, which brings us to the question as to why reimagine now, right? What is the timing here for smart manufacturing in India? So the takeaway here is, if you stand still, you're going to move backwards, which means you have to do something. It's like if you look at startup companies, every startup company grows, but they reach a phase where if they are stagnant, they actually fall. And they have to constantly strive to reinvent themselves and keep growing. So we are kind of in that phase in the manufacturing industry in India. So one is market volatility, right? Especially in the automotive industry, there are significant fluctuations. There are brand new technologies coming in, which are putting in associated constraints in manufacturing, right? And you must stay agile to adapt to these changes. Second is your own consumer expectations, your own customers, right? So they have more and more expectations for technology and quality and of course sustainability. And you have to gear up to meet that. And sustainability is a huge deal for us. Skilled labor shortage is only getting worse by the year. There are very specific points in the manufacturing process that need skilled labor. And that shortage is getting worse in every single industry. If you take, there was one project that I had worked on several years ago, which is just like there are tea tasters, there are people who smell these agarbatis, and they are absolute skilled experts at smelling those agarbatis, those perfumes, right? And it's very hard to replace a job like that. It's a highly skilled job, and these people are highly paid. And somebody came to us and said, can you develop an automated AI-based system, which is a combination of an electronic nose and the software, which can decipher what that nose is smelling into its component chemicals and therefore predict the kind of perfume that it is, right? So people are thinking along those lines in terms of skilled labor shortage, right? So these are some of the pressing reasons that we need to imagine right now, and it's India's moment. So India has a young and tech-savvy workforce, and the China Plus One strategy is actually panning out. And government initiatives are truly supporting smart manufacturing growth. And I'm just listed one of these initiatives here, Samarth Udyog Bharat 4.0. It's essentially geared towards Industry 4.0. So government is actually supporting. So how do we start using those incentives to get into the smart manufacturing space? Okay. Having said that, there are of course challenges that are very unique to India. The MSME sector in particular, which is the majority manufacturing sector in India, is definitely facing a readiness challenge. And as I said early on, I mean, the main point is just how do I get the basic quality and the timely output out? Just fulfilling people's needs appears to be the biggest issue, right? And there's infrastructure issues, there's power supplies issues, there's internet issues, and there are still skill gaps which persist in the manufacturing workforce, right? And finally, fragmented supply chain digitization, which means even if you become smarter and smarter and smarter, is your supply chain going to keep up and is it going to help you? But can you convert all of this to an opportunity, right? Because once we list the problems, we know that these problems are real, but then the smart way to do things is actually to try and convert these problems to an opportunity. And we'll talk a little bit about that. So one question is, can Indian suppliers, especially automotive suppliers, evolve from tier 1 to what they call tier 0.5, which means closer to the OEM, right? So can you evolve from a supplier to a true partner, which means can you work more closely with the OEM? Can you understand the OEM's requirement? Can you jointly develop projects of interest, processes of interest, components of interest moving forward in partnership, right? So that gets you much closer to the OEM itself, right? And just use smart manufacturing as a differentiator, saying that I have done these smart things in my manufacturing process and that sets me apart, right? So to me, these are the challenges, but converting them to the opportunities is the smart thing to do. Okay, challenges unique to India, continuation. Many myths, but unfortunately the reality has to hold, right? People think smart manufacturing is too expensive, but it's not. You can go step by step. You can do a very modular adoption. You don't have to go in for the world, right? Second one, people think it's too complex. Today there are plug and play solutions available, which make your adoption of smart manufacturing pretty simple. I was just chatting with some people in the morning, and I'm sure you'll hear about some of those solutions that people are eager to talk about today. Finally, there's a myth that it actually replaces jobs, which is absolutely not true. It just reshapes the job. It's a little bit of a different skill set. You want people from upgrading from just an operator to a smarter operator, right? And you want that person to work with the machine. And that's about it. It's not at all about replacing jobs. So to highlight some of these points, and in closing a few slides, let me just pick a few light-hearted thoughts, right? A lot of it based on my own experience and with the theme that let's show some simple examples to show where a normal Indian manufacturing company can actually try and get to something smart. Okay? So first example, an interesting fact, this is an AI generated image. I gave my experience to ChatGPT and it actually gave me this image. So the biggest problem that we used to face, personally, in my experience, if I look out the shop floor through a window, maybe on little height, first thing I will find at any time of the day is that little groups are forming. Okay? And I'm sure it's a common problem. So this is a little bit of an exaggerated image. Why does this form? Because somebody will have some problem with their workstation. They'll just call a friend over, and that guy will just move over from his workstation. And that'll slowly form a group of 3 or 4 or 5 people. They'll start discussing. It's all in good spirit, but it actually happens, right? So, a very simple, down-to-earth kind of problem. How can you use basic smart manufacturing techniques to get around and improve something like this, right? So there are solutions today which, to start with, will actually tell you how bad this problem is, which is simple video analytics on groupings. You can put some very basic, simple cameras with some simple software, AI-based, which will tell you that so many groupings are happening in your shop floor throughout the day, and this is the magnitude of your problem. It's either small or medium or large, right? And then there are many, many simple solutions. And I would wrap up all this into the gamut of what we call smart manufacturing, right? These are actual implemented solutions in various practical situations. In some factories, you simply provide supervisors an elevated platform, which means they have a better visibility across the entire shop floor. And they can actually spot these groupings. They can immediately go there for help. They can either break the group or solve the problem so that the group breaks itself, right? Next point, you can actually have planned brief exchanges among workers, which means you make groups happen intentionally once in a while, 2 or 3 times during the day, right? And then whatever common problems they have, they start talking about. And then you can get to the root cause. Why are these groups actually forming? Are there issues because you have poor layout? There is actually some bottlenecks happening at certain production stations. Is it lack of training, right? Or maybe just not enough people at certain production stations, right? And finally, engage workers in solving the issue. And the last point, which actually works globally in many places, is giving people color-coded flags. They actually simply raise the flag if they need help, and the supervisor goes to support, and if they actually need some more people in the shop floor, the supervisor in the process understands the root cause of these issues and it helps them solve it, right? So this is one challenge. Second challenge, I think, is a very common challenge, plan versus actual. You plan something in terms of timeline. I want to achieve this much production this month or this week or today. Doesn't happen, right? The planning is way off. And here is another place where you can go a little smart and hope to achieve some benefits in smart manufacturing. It's so difficult, right? Even a conference like today, you may plan to get it over by 5 o'clock and it may spill over to 6 or 6:30. So it's even hard to plan one day's worth of talks. So how do you plan something like production, which is complex, which has a lot of different steps in it? So a couple of things. The deviation happens more in non-assembly line kind of tasks, where you have individual workstations. It depends on the skill of the worker. So there's a manual welding step, for instance. You will actually see more deviation, more standard deviation happening in terms of the planned time. And then it happens a lot with external factors. How often have you called a vendor, the vendor says, no, I'm working on your job right now, I'm going to send it to you tomorrow. And then tomorrow happens and then you just don't get it, right? What the vendor promised you simply doesn't happen, right? So there are issues like that which will overall delay your production timeline. And there are smart ways to get around it, right? So dashboards, simple dashboards at critical workstations. What is happening at that workstation? Is it per plan, what is the deviation at that workstation versus plan, right? Simple dashboards, right? Predictive maintenance, which we already spoke about. How do you predict failure before it happens so that you can actually prevent downtime, right? And downtime is a major predictor of delays. Real-time and digital work instructions, can you actually tailor and customize work instructions depending on how things are moving in a certain workstation in your production line, right? And can you also force your suppliers to have equivalent digital dashboards at some level, high level, detailed level, up to you? And can suppliers share it with you so that you proactively switch your lines in terms of production based on how much your suppliers are getting delayed? None of this is super high tech, and I think all of this can be implemented in an Indian environment quite easily, right? And finally, if you want to go all the way up to digital twins, I think that will truly solve your problem in terms of getting things happening on time. So another one, fragmented vendor ecosystem and something like Jugaad, which is, I'm not against Jugaad, it's a great thing, something we have in India. But in a lot of manufacturing scenarios, the fragmentation is a big deal. People have a whole bunch of vendors. So you're multiplying your risk in terms of not getting things done on time. So some of the smart ways to solve something like that would be, can you identify your key strategic partners among these vendors, only work with them, allow them to manage the other vendors, right? So that's one smart way to solve these problems. Can you consider supporting these key vendors? Can you actually do capability building? Can you maintain transparent scorecards with these vendors and actively work with them to solve, right? And if you do end up having multiple small vendors, which ultimately may be the case, even very, very simple technology like forming a WhatsApp group, right, is a smart thing to do, right? And you just form a WhatsApp group with a bunch of vendors who are related. You make them post images, you make them post updates. And images are great because it actually validates what people are saying. And that's it. And that alone would help you. Yeah. So, and things like Jugaad encourages agile innovation. But then can you follow up Jugaad with actual root cause analysis, right? And leading to preventive action. So can you formalize the Jugaad after the fact that Jugaad has actually happened? So things like that. So I'll end with this. It's a whole bunch of challenges, very much in the Indian context. If you have frequent power fluctuations, very Indian problem, it's your chance to go green. You will actually achieve some ESG targets, and you will also satisfy your customer because you've gone green, and you will solve your power problem to a large extent. Right? Too much dependent on skilled operators. Can you consider extensive training programs? Can you consider selective automation? Can you consider AI-supported processes in those skill steps? You can't completely replace the skilled operator. Can you a little bit support with AI? Like CNC programming is classic. Today, you can almost completely automate CNC programming. If you give the machine and if you say that this is the part that I want, you can almost generate the programs completely by yourself, right? Unpredictable logistics. There are smart inventory tools that keep adjusting your inventory levels day to day based on conditions that are happening with your suppliers, conditions that are happening in weather, conditions that are happening in logistics delays and so on, right? And you can insist on GPS tags on all parts, very simple but effective. And finally, worker digital literacy issues, local language, icon-based input, voice-assisted input, mobile app-based inputs, all of these will help you actually make the workers enter data into the system, which makes your system smarter. So this is, I'm just going to close this and take any questions. So this is an LA Times, Los Angeles Times headline of an Indian factory. Just wanted to say that it's also a smart thing to be safe. So safety is paramount. This is a fire at a denim factory in India, and there was only one exit, and people had to climb a ladder to get to that exit, so it was a disaster, right? And this made headlines abroad, which means it gives you really negative imagery, right? So the converse of the statement, which means it is not smart to find a way around safety. I think that's the better message out of this slide. And something for you to ponder. Are you going to start your digitization journey right away? Right? So you can look at that joke. Who led the digital transformation of your company? Is it your CEO or CTO, or was it COVID? Who forced you to do it? So the question becomes, are you going to wait for the next crisis before you decide to become smart in manufacturing? Or are you going to proactively take the step and actually do it? Right? So something to consider. And finally, start small and think big. So I think every company in India that's into manufacturing can actually get into smart manufacturing today. I've just listed some KPIs. Basic stuff. It may or may not apply to you. Like scrap rates is a common thing. Energy use per unit is a common thing, right? Downtime due to failures is a common thing. So you can pick any one of these topics. And one process, one line, measurable ROI. Pick one process. Pick one line in your production unit, right? Keep a 90-day timeline. Just do a pilot, low cost. Get a partner on board. Try it out. See if it works for you, right? See if going smart actually works for you. And as I said, going smart is not only about fancy things. It's about simple, small innovations. And finally, you have to not just keep machines in mind, but you have to keep people in mind. It's the combination of people and machines and intelligence which is the real smart thing to do in the future. The clip you're seeing here, it's a 40-second clip, I'll just play it, is when assembly lines were first introduced, which was the first smart thing that ever happened in manufacturing. This is a Charlie Chaplin movie. It's called Modern Times. Many of you may have seen it. The Chaplin's role here is to just turn 2 bolts in that assembly line. He has no idea what product is actually being made. He is just one worker in that assembly line. It just shows you in a comedic sense that if you ignore the people, right, then, I mean, you kind of have lost it in terms of the manufacturing. So I hope this one plays, yeah. Audio isn't coming, but he's just turning those 2 bolts. So this was a very famous parody that Charlie Chaplin took on at that time, the modern assembly line style of manufacturing. So just to show you that you cannot ignore the people are actually a very big part of this, right? So the future is not simply automation, right? It's how you marry people's sentiments, automation, and finally both real and artificial intelligence. So with that, I'll stop. Thank you very much.